Hello everyone. Today we're going to talk about atoms and molecules. Basically, we're talking about chemistry. Everything is made of chemicals, and in biology we have to understand that all sorts of chemicals have an impact on life. So let's get down to the nitty-gritty here. And every atom is composed of three parts. The nucleus of the atom, which is composed of protons and neutrons. Protons have a positive charge. Neutrons do not have a charge. And in the outer area surrounding that nucleus, we have our energy particle, the electron. So that's just a basic description of the atom. Let's see what else we have here. Okay, these orbitals. All right, we have our nucleus and the area that the electrons move around outside the nucleus. Those are called orbitals. And each atom, different kind of atom, has a different number of electrons and a different number of orbitals. Okay, so we have our nucleus with protons and neutrons here. This is a nitrogen atom. What we want to do first is we have our, for purposes of biology, I'm really not going to get into orbitals and shells and, make you learn all the different orbitals, all the different shells. The orbitals give the atom its shape, you might say, and the shells are the energy levels of those electrons. You'll learn more about that in chemistry. What I want you to understand here is that there are a certain number of electrons that are in each of these outer areas here, these shells or orbitals. And there are maximum numbers that each of these energy levels can have. So for instance, in nitrogen, the nitrogen has 7 electrons spinning around and outside of the nucleus. So it will fill its first energy level with 2, because that's the maximum number that it can have. And then we go out to the next energy level, and there's a maximum of 8 electrons that will fill that outer energy level or outer shell. And so we see here that 2 of these electrons paired up, and electrons do like to pair up. That's another thing they like to do. So we have some that are paired up already, and we have these 3 here that don't have a partner. Well, those are ready to bond. So that's how, bonding occurs, when you have these free electrons here ready to bond with another atom. Let's see what else okay, just showing you some more of these orbitals. Like I say, this is more chemistry stuff, and as long as you know the electron, proton, neutron, and as long as you know that we have electrons on the inner shells, and there's specific numbers of electrons that can fit in those shells, that's good enough for me. So don't get too deep into this, because I don't want you to get all worried that I'm going to test you on specific numbers and what p orbital it is, and I'm not going to do that. I just want you to know the basics. So let's take a look at the periodic table. you can see that the periodic table is, it's giving us the symbol for the element and the atomic mass, and it has the proton in here, and then it has the electron. It's really showing an electron dot formula here. Okay, so for instance, sodium, we have our chemical symbol Na, and then we see that we have the first energy level here. The first shell is filled, the second shell is filled because there's 8, and then the third shell has 1. Okay? But the third shell will also fill with 8. So we go down here to argon, and we see that this is a very stable element. The unstable elements, or the ones that have this single electron in their outer shell, ready to bond, ready to jump out and bond. So that's what this is all about. These are electron dot formulas. This is a little bit about the periodic table. And as biology majors, you should, taking this class, you should become familiar with, the periodic table and element names and symbols and these types of things. So let's see what else we got here. Atomic mass. Okay. You can read through some of these things in your book. This is just a outline of what information is in the book. I want you to read through it. I'm not going to test you on the Dalton or the mole. That's more of chemistry stuff. I might ask you what an isotope is and how they are used. Yes. Yes, very important. What compounds, what elements make up living things. Very important here. Hydrogen, oxygen, carbon, and nitrogen. See, we are basically made of chemicals, so you should know something about chemicals. So read through your book, learn these chemicals that are essential for life, know the trace elements we need in just teeny tiny amounts. We get these mostly by eating our vegetables. Green leafy vegetables give us a lot of these. Okay. Chemical bonds and molecules. Okay, this I believe is going to start a new mini lecture. So I'm going to stop here, and I'll see you next time.